So this is the continuation of our Unit 1 PowerPoint, because in chemistry we want to be able to make accurate and precise measurements. We want to be able to report those measurements with the correct number of significant figures, reading the instrument as carefully as possible, and then estimating the last place. We also want to be able to convert our units of measure. And so in chemistry, we're going to use the metric system. Now, the metric system is super simple because, and you've probably studied it before, it's based on units of 10. And so we have, for the metric system, there is a base unit. The base units, if you wish to measure mass, are grams, volume is length, meters is length, volume is liters, and then time and temperature. And so what the metric system has done is divide each of those base units, like meters, into 10 parts. And each one of those, it has a prefix. So 10 parts of a base unit is a deci. Then we take those base units, we can divide it into 10 more parts. So that's 100th of the base unit. That's centi. We can divide those centimeters or centiliters or centigrams into 10 parts. And that would be a milli. So that would be 1,000th of the base unit. Then the next one you don't need to know. We can divide it into 10 and then into 10 into actually 1,000. It would be micro. And then 1,000 more parts would be nano. We can also take that base unit and we can go in the other direction and we can put 10 of the base units together. So if we put 10 meters together, that's a decameter. We typically use the capital D for that. 10 of those together, it's a hecto. 10 of those together, it's a kilo. And then if you put 1,000 of those together, it would be a mega. And so that's how the metric system is arranged. Now, in order to remember that, I use this old acronym, King, Hershey, does, then our base unit. And some people say make, like, get for meters, liters and grams, delicious chocolate milk. Then I just remember 2 spaces to micro, 2 more spaces to nano. And so we're going to do a little bit of practice with those. You do need to be able to convert units of measure without changing your measurement, keeping that accurate, precise measurement, and making sure that you have the correct number of significant figures. And so if we do some practice, this would be a great time for you to stop the video or maybe watch the first example and then try on your own. And so the way that I typically do this is I look at what I'm going to start with. So in this first one, I'm starting with 5.6 meters. So that's going to be right here at my base unit. And I want to go to millimeters. So I'm going to go 1, 2, 3 spaces. And so what I'm going to do then is I'm going to take this decimal and I'm going to move it in that same direction. 1, 2, 3. I'm going to put zeros in there. And so 5.6 meters. Oops, excuse me. 5.6 meters becomes 5,600 millimeters. So take a moment, pause the video, and see if you can do these. All right, so as you're taking a look at each of these, hopefully you can see how I converted the units. Notice that each of my measurements has 2 significant figures. Each of my converted measurements has 2 significant figures. And so all I do is orient myself. Where am I starting? I do the correct number of jumps, and then I add zeros or move my decimal place to accommodate that number of jumps going in that same direction. So I hope you did well on those. On the homework that's due Saturday, there are some of those for you to do as well. And so here's just another way of taking a look at this if you need another look. So if you had 4 meters, for example, or excuse me, 4 kilometers, and you were going to change that to meters, you're going to go 3 jumps to the right and add zeros in those places, so it becomes 4,000 millimeters. So again, this is just another way of taking a look at it. And so as we're using the metric system, you do need to know many of the units in the metric system and the abbreviations. So this is just a handy dandy little chart to help you as you're working through the metric system. Now, sometimes as we're converting units, we may have to convert from metric units to English units or English to metric. And so we can't simply jump and add zeros and take away zeros. And so we use a strategy called dimensional analysis, where we turn a quantity that's equal to 1 into a fraction. So 1 foot is 12 inch, so that may be one thing that we'll use, and we would write that as a fraction. Now, that's super easy to write as a fraction because I can just say 1 foot over 12 inches, or I can say 12 inches over 1 foot. And we may write it in the first way, we may write it the second way, depending upon what we're going to do. We use these to cancel out units because remember, in chemistry, units are super important. Every measurement must have a unit. And so that's what we're going to be using in dimensional analysis. Oh, I forgot this had sound. All right, I'm going to speed up through this without the sound. All right, and so 60 seconds in 1 minute, so we can write that as a fraction with 60 seconds on the top or the bottom. All right, what about days to years? Hopefully you were thinking that. All right, and so what you want to do, here's the steps to solve dimensional analysis problems. Now in the homework for homework number 1, you actually have to drag tiles over as you're writing these. So that can be a little bit tricky. And so I write down what I'm given first. Then I write an X in a line and I put the given unit on the side of the line so it will cancel out with the other one. Like if I was in math class back in, I don't know, I guess middle school, right? And I had this X times 1 over X. What does that equal? Hopefully you're thinking, well, those two X's are going to cancel out. That's going to equal 1. And that's exactly what we're going to do as we're doing dimensional analysis. Then then you fill in the numbers. Then you simply do the math. Multiply the top two numbers or 2 or 3 or 4 numbers together, and then divide by what's on the bottom. And let's see some examples. So how many minutes in a year? Okay, so I'm starting with 1 year. You've always got to look at the problem for what information the problem gives. And that's where you always want to start and write that down. A year. So I made that 1 year. Well, I don't know how many minutes in a year, but I do know. So I'm going to draw my line, put my X or 1. I'm going to put this is just a placekeeper. I don't necessarily need it. Then I'm going to put year on the bottom because that way they're going to cancel out or diagonally drop, as you've probably seen in our videos. So those cancel out. And so what's the relationship between days and years? 365 days is 1 year. My years are then going to cancel out, but I'm still not at minutes. But I do know that days and hours, I know that there's 24 hours in 1 day. So now my days will cancel out, as you can see. And then I know that there are 60 minutes in 1 hour. And so my hours are going to cancel out, and I would be left with 525,600 minutes. Now, of course, I would have to round this to 500,000 minutes because I only started with one significant figure. Okay, Here's another one. If we're in a 10-kilometer run, how long would that be in miles? And here is our conversion factor. This is the relationship we're going to want to write as 1. All right, so first step, always the same. Look at what information the problem gives us and write it down. And so that's what I'm going to start with. I'm going to write that 10 kilometers, and I'm going to put that over 1. And then I'm simply going to fill in my relationship. Next to it, I can put this, draw a line, put this over 1, or I can just leave it as it is. It doesn't matter. Now let's see, I'm going to want to put kilometers down here so that these will diagonally drop or cancel out. I'm going to put miles up here. Let's see, 1 goes with miles, 1.609 goes with kilometers. Now I'm going to multiply straight across the top. So 10 times 1 is 10. 1 times 1.609 is 1.609. And then I'm going to divide 10 divided by 1.609 gives me 6.2. So I'm going to take that 6.2. That's now going to be miles because my kilometers canceled out. And I'm going to have to round that because my measurement, I can go 6.22. I actually get 6.215. There are three significant figures in my measurement. And so I can keep my answer then to 3 significant figures. Here's a couple more examples for you. And so I would suggest that you try those on your own. I've done those on paper because it's a little bit easier than writing on the computer screen, as I'm sure you can imagine. And so once again, I'm always going to look at what my problem gives me. I see I've got 8.7 liters. I notice there's 2 significant figures. So when I worked out the problem, I get 2.3 gallons. Now in the homework, you're not going to be able to just write that. You're actually going to have to make a little tile and drag 8.7 liters over. And then you're going to have to drag over tiles for your conversion factor. All right. Now this next one is a little bit tricky. And so I'm going to show you how to do this one. So we're starting with 452 meters per second. And so I'm going to write that down because that's what I have to start with. And that's where you always need to start. And then I'm going to, So I've got to convert my meters to miles. And so here's my conversion factor for that. So I'm going to want to put my meters on the bottom so that they will cancel out. And I'm going to want to put my miles on the top. And this is a more tricky one because we've got 2 different units that we're converting here. Next to meters, I'm going to put 1609. Next to miles, I'm going to put 1. And then I'm going to kind of note that my meters canceled. So I've got miles. Now I've got to convert seconds, seconds to hours. And so I'm given seconds and hours. And so I'm going to want my seconds to cancel out. So I'm going to put seconds up here. Then I'm going to put hours over here. The number with hours is 1. The number with seconds is 3,600. So these would be little squares on the homework that you have to drag over. And now I'm simply going to do the math. 452 times 1 times 3,600 equals 1,627,200, and that's going to be miles. And on the bottom, I'm going to have 1609 times 1. So that's going to be 1609. And that's going to be hours, because that's what I was trying to convert. I was trying to convert meters per second to miles per hour. So let me make that hour. And then I'm going to simply divide. Divided by 1.609. 1011.3. 1011.3. And that's going to be miles per hour, but I'm out of screen there. But now I've got to take a look back at my problem, and I see I have 3 significant figures. So I'm going to have to round this to 1010, or I could put it in scientific notation. 1.01 times 10 to the third miles per hour. Here's some more for you to try. There are quite a few density problems in the homework, and so density is similar to that meters per hour and miles per hour problem that we just did. And then I wanted to mention heat, because our video is getting a little long here. When we're measuring heat energy or the internal energy of something, the tool we use is a thermometer, and the units that we use, we measure that temperature, which is equal actually to the kinetic energy of the particles that are in there that are moving. And the way that I'm just going to skip this slide here, and the kelvins are the way that we do that. And so in order to have temperature in Kelvin, you first have to measure it in degrees Celsius. Then you add 273. And 273 is perfectly fine. You don't have to have the 0.15 to add those 2 more significant figures. And so you want to simply practice that, converting our temperature scales. If you have if you're trying to find temperatures in degrees Fahrenheit, just multiply by your Celsius temperature by 1.8 and add 32. So I would suggest that you follow those formulas and practice these ones on the right. So if we have 230 degrees Fahrenheit, we convert to Celsius. So we have to take our Fahrenheit minus 32 divided by 1.8, and you can check your answers right there. All right, well, your first week is a little busy. I hope that this video helps you as you're working through the other videos that we've already made previously and are posted on Dell Tech, as well as the PowerPoints. If you have any questions, just let me know.